Welcome back. In this section, we are going to explore places in the body that are considered lymphatic sites. So this includes sites where these lymphocytes are made, where they mature, and there's only two of those, red bone marrow and thymus. And then we'll move on to areas in the body where they're stored or they get put to work. And there are many sites of this, including your spleen, your lymph node, as well as a lot of various tissues. So let's go ahead and get started and learn where these are made. So as you know by now, the red bone marrow is where hematopoiesis occur. And this is where the precursors for both the B cells and the T cells originate, as well as the precursor for the natural killer cell because it's the same. However, only the B cells and natural killer cells will mature here. So if you recall, we have that stem cell at the very top, that hemocytoblast, from which we get both the myeloid stem cells and the lymphoid stem cells. And the lymphoid stem cells are the ones that give rise to the lymphocytes and the natural killer cells. And so from the lymphoid stem cell, we'll have a B lymphoblast, which will give us B cells. We have a precursor for the natural killer cells as well. And then we have a T lymphoblast, which will give us T cells, but not in the red bone marrow. The precursor, the T lymphoblast, actually leaves the red bone marrow. So if you remember B cells for bone marrow, that's where they originate. And the B actually didn't come from bone marrow. It came from something in a bird called the Bursa fabricus, but it works really well for humans. In contrast to the B cells in the bone marrow, the T cells are made in a different location. So how does this happen? Well, in the red bone marrow, remember, we have all these precursor cells, and we also have sinusoidal capillaries, okay? And so it will allow cells to enter into the bloodstream. So mature B cells and mature natural killer cells will enter the bloodstream, but immature T precursor cells will also enter the bloodstream. So what is that natural killer cell? Well, it is an amazing cell, and it surveys your entire body. And it is capable of killing cells directly. That's how it got its name. It naturally kills stuff. And so it also could be said to be cytotoxic, as in toxic to other cells. And so, for instance, it can recognize and kill cells that contain pathogens. For instance, if you have a macrophage that has engulfed something, or if there is a pathogen itself that has invaded the cell and it hasn't been attacked by a macrophage, it can engulf the cell with the pathogen. And it also has a very strong role in destroying any tumor or early tumor precursor cells that your body may make. So how does it kill? How is it cytotoxic? Well, the natural killer cell has Golgi apparatus, and from the Golgi apparatus, it has these vesicles that contain a couple of different chemicals, and one of them is a chemical that when it's released and it goes to the other cell, it can actually poke little holes in the surface of the cell, which lets stuff enter that cell. And one of the things that enters the cell are enzymes from the natural killer cell, which induce it to undergo apoptosis, or pre-programmed cell suicide. If you'd like more detail about how this occurs, there's a tiny little graphic I've posted for you, which is a really good explanation of it. So moving on to the second site of lymphocyte maturation, that is the thymus with a T, because this is where your T cells are made. And so most of you have never heard of the thymus because it really is not a big organ in adults. It actually sits in your superior mediastinum anterior to those great vessels and the upper part of your heart, over the atrium. However, by the time you hit puberty, it starts involuting, which means before puberty, whatever cells are in there, so those lymphoid stem cells and those T lymphoblasts, which have moved there, they will start producing more and more T lymphocytes. But after puberty, those immature stem cells, they disappear and the thymus gets replaced about 95% with adipose tissue. But you had mature T cells there. So what happens are the T cells that were left there, they undergo mitosis, okay? And so one can be called to duty and there would still be one left behind to undergo mitosis. And so there are hormones involved in this process, like the thymus has a hormone called thymosin. As well, there are other molecules which signal it to do its job of proliferating. And we'll talk more of those later when we get to functions of the immune system. Just realize that the vast majority of your T cells in your thymus never get called to duty. So you have plenty of them. Looking at the histology of the thymus, it has an outer cortex or cortical area and an inner medulla, and there are different cell types in each area. If you look at this picture, you can see the part labeled cortex. It's very dark, and that's because when we look at the cells, it has a higher amount of the cell being occupied by the nucleus, because these tend to be our more immature cells, also known as thymocytes. They're immature T cells which haven't developed yet. As you get into the junction to the medulla, we are going to start finding macrophages and dendritic cells, which I'll talk more about later on. And then in the medulla, we have our mature T cells. And as I alluded to before, only about 5% of the mature T cells that your body makes will ever be called to duty. Now, the thymus is interesting in that it has its own equivalent to the blood-brain barrier that we call the blood-thymic barrier. It's one of the 3 areas in the body where we have this. And the reason for this is, and remember, this barrier means that there are tight junctions between the epithelial cells of the blood vessels, so that the mature white blood cells that are in the blood vessels cannot create an immune response against what's going on outside the blood vessel. And that's because if they could see these immature T cells, they would say, man, there's something wrong with them. And the natural killer cells and the other cells would come and phagocytose them. So the T cells, while they're in the thymus, they are protected by this blood-thymic barrier, so they will never take part in an immune response. They have to be released into the bloodstream in order to be active. Now, the largest lymphoid organ is the spleen. And so we are done with the 2 sites where lymphocytes are created and hang out. Now we're sites where they're going to work. So your spleen is in your left upper quadrant, tucked underneath your rib cage and just below your diaphragm. And because it's adjacent to the ribs, it's susceptible to trauma. And it's just kind of like a soft, really smushy bag chock full of blood cells. Okay, it's not a solid organ. And this is a place in your body, because it doesn't have structure, has a lot of reticular connective tissue. And there also is a dense, irregular capsule on the outside of the spleen. So on the bottom, I've taken an outside picture of the spleen, and the spleens usually are about this big, but they're variable in size. And then I've taken a slice of the spleen and looked up close, because what you can notice, it is not homogeneous. You have areas that are darker and areas where you can see these little white spots. So there's no outer cortex inner medulla, but instead there is what we call red pulp and white pulp. The red areas and the white areas. As you can see, the vast majority of it is not the white pulp. So Looking at it histologically, what you'll notice is the white pulp looks like these circles that are completely surrounded by red pulp. But they're really not circles or ovals, they are cylinders. And these cylinders are surrounding a blood vessel, a little arteriole inside the spleen. And this is a cylinder chock full of lymphocytes and macrophages. And its job is to monitor the blood to see if there's any antigens in the blood that it needs to initiate an immune response for. And it also serves kind of as a reservoir of monocytes waiting if there needed to be macrophages elsewhere in the body, then we've got a bunch of extra ones sitting here as well that we can immediately release to go to work. Now, in contrast to the white pulp, the red pulp basically are these huge sinusoidal capillaries filled with erythrocytes. In fact, it can act as a blood reservoir. Up to a liter of blood can be stored in your spleen normally. And because they're sinusoidal capillaries, they easily let red blood cells exit. And then the surrounding macrophages can find the damaged red blood cells and engulf them. The macrophages also can find bacteria in the blood and engulf them as well, so preventing you from becoming sick. The next type of lymphoid organ that you know about is called the lymph nodes, and these occur along the pathway of our lymph vessels. They also have an abundance of reticular connective tissue because they are just mostly white blood cells of various types. And their job is not to filter the blood like the spleen, their job is to filter lymph because that's why they're attached to the lymph vessels. Now, they're often found in clusters, especially like in the cervical area, which means your neck area, axilla, your groin, and along your aorta, as you can see in this picture. And so the reason why you have clusters is because each lymph node filters the lymph. And so it's kind of like putting the lymph through a strainer, and what comes out may be clean, may not be totally clean. So we're going to put it through another filter and another filter and another filter. And hopefully all the bad stuff will be caught as it travels along all the clustered lymph nodes. And if it finds something that it doesn't want or that's bad for your body, the antigens that are caught can stimulate the white blood cells in the lymph node to start an immune response. And if you get an immune response, you'll have the increase in cell numbers being brought to that lymph node, so it will increase in size, and you can palpate or feel these lymph nodes. And in this lady, you can clearly see a group of cervical lymph nodes on the posterior side. So she obviously has something going on in the back of her head. Many of us have felt our anterior cervical lymph nodes right at the angle of the jaw, for instance, when you have strep throat or a really bad viral pharyngitis. So looking at the microanatomy of a lymph node, what you notice are those lymph vessels are draining into it. So the lymph node is kind of a bean shape, and the lymph flow is from the outer part into the lymph node, but then, and those would be called afferent lymph vessels, but then we also have efferent lymph vessels which leave from the dimple or the hilum area of the lymph node. And lymph nodes do have an outer thin connective tissue capsule, and just under that capsule, that's where the lymph gets dumped in. And so that's where all the bad stuff first appears, right under the capsule and what's called a subcapsular sinus. Okay. So lots of macrophages can be found in that area getting to work. So let's look at it in a little bit more detail. When you look at this lymph node, This one shows our afferent lymph vessels, and then you can see the subcapsular sinus right underneath it, and you can see at the hilum of the lymph node on the other side, efferent lymph vessels, which means the lymph is going to percolate from the sinus and percolate through all the other white blood cells before it hits the efferent lymphatic vessels. So the fact that the lymph node is not homogeneous tells you that there is some organization to the lymph node. And so it has an outer cortex and an inner medulla. And in the outer cortex, you can see these rounded structures, lymphoid or lymphatic follicles. And when you look at them, the outer part of them is darker, and this is the part that contains mostly immature T cells. And the central part is paler, and this contains B cells, especially B cells. This is where they're going to become activated, because then those cells have a lot more cytoplasm, and that makes them look paler compared to the cells just hanging around waiting to be activated. So that's why you have this darker outer part and the paler inner part. When they're activated, they become a cell known as a plasma cell. So in the medulla, we really don't have any organization, and so we will find macrophages scattered in there. We will find various lymphocytes, and we will find those plasma cells, those activated B cells. Okay. So at this point, I would like you to look at this histology of a lymph node, and I have marked different things for you to label. And I started with the first one and labeled it the cortex, so you could figure out where you were, because I think you can see the capsule and the adipose tissue surrounding the lymph node. So go ahead and pause the video and label it as indicated. All right, thank you for doing that. So let's continue on, and I have another exercise for you to do, and that is for you now to draw in your lymph pathway and put your lymph nodes and structures related to that in it. And now you have 6 different things to try to label on this pathway. So go ahead and stop it again and see if you can work this one out. And remember, if you get stuck on these, feel free to contact me, and I'm able to help you. All right, going off on a tangent for a second, I want to talk about lymphoma, because as you recall, when we were talking about white blood cells, if there's a malignancy of it in tissue, we call it lymphoma. So they're often diagnosed in lymph nodes lymphoma. And so if it is in one localized area, that's the best news. If it's on 2 locations on the same side of the diaphragm, that's a little bit worse news. If it's on both sides of the diaphragm, that's even worse. And if it's not only in the tissues, but it's also found in your bone marrow, that's the worst staging. So I don't want you to learn stage 1, 2, 3, 4, but I want you to understand how we can stage it just on locations. So there are a lot of different types of lymphoma, but we can divide them in 2 broad categories. And the first category are called non-Hodgkin's lymphoma. And there are more than a dozen different types of non-Hodgkin lymphoma. And some of them are the type that you can live with for 20 years. You will die with the disease, but not because of the disease. Where others, the cell type is super aggressive and it can kill you within 1 to 3 months. So the thing about non-Hodgkin's lymphoma is a lot of research has been done, and we in the last 30 years have made huge strides and had many cures in childhood lymphomas. And types of childhood lymphomas that used to be 80 to 90% fatal are now like 90% curable. Okay, not living with disease, but you are cured of your lymphoma, and that's great news. So if non-Hodgkin's lymphoma is one big category, it kind of makes sense that the other category is Hodgkin lymphoma. And this is the one that's probably most relevant to you right now because the peak ages for diagnosis are between 19 and 25, which is where most college age students fall. And in fact, it is not uncommon at the larger schools where you have a couple of hundred people taking anatomy every semester, for at least one of the anatomy students either had to have had Hodgkin's or be diagnosed with Hodgkin's while they are taking their prerequisite science classes. So overall, Hodgkin's is less common than all the non-Hodgkin's together. There are different varieties of Hodgkin's as well, but the good news is overall, it's about 85% curable. So if you had to pick a cancer to get, it's not a bad one. There is some association with infectious mononucleosis, which is a viral infection with Epstein-Barr virus. And this is one of the interesting cancers that is more often diagnosed in men than women. All right, moving on from the lymph nodes to things you've probably never heard of, and these have a lot of different names, but basically we can have diffuse lymphatic tissues, which are also called lymphoid tissues, or we can have discrete lymphatic nodules known as lymph nodules, not nodes, but nodules, lymphatic nodules, lymphoid follicles, lymph follicles. There's a lot of synonyms. And both of them do the exact same job. Okay, the nodule is just telling you it has a certain structure, and the diffuse one just means it's homogeneous throughout. I'll show you pictures. But both of these are looking for antigens, and they will attack and destroy antigens and create an immune response. So where they are found is in the connective tissue. And these are going to be mostly T lymphocytes, okay? And so you have this oval collection, if it's a nodule, with the darker outer part and the paler central part, okay? The outer part, the rim, is called the mantle, and these are the resting lymphocytes. And the inner part, these are the activated cells because they have more cytoplasm. So we would find those plasma cells here in macrophages. Okay. Whereas in the diffuse tissue, there is no organizational, there is no germinal center. Okay. So these are the same types of germinal centers found in tissue like we found in lymph nodes, but these are not in a lymph node, as you can see on both the pictures on the left as well as the right. You can see an epithelial surface. So these are not lymph nodes. Okay. And here is an example of another place in the intestine where you can see both a diffuse lymphatic tissue in this area as well as discrete nodules in other areas. So they coexist with each other, and there's no import if it's one way or the other way. Which brings me to something called MALT, which is mucosa-associated lymphoid tissue. And so all this means is we have either diffuse or follicular lymphoid tissue that is below a mucosa, so below epithelium. So this is found in the respiratory tract, in your genital tract, in your digestive tract, from your mouth to the anus. In your small intestine, we tend to have lots of them with very obvious germinal centers, and they actually have a name called Peyer's patches, but you don't need to know this. We have a lot of this, the entire GI tract, especially in the appendix. And your tonsils are an example of MALT. Okay, this is the first site to meet pathogens that are entering through your nose and your mouth. So this is both a respiratory and digestive system. Yes, your tonsils have those little crypts which can trap stuff and give you bad breath, and you go, oh, this is gross. But what they're doing is they're going to trap those antigens, and the lymphoid cells next to it can generate an immune response, thereby preventing those germs from entering your body, which is awesome. So at this point, I think we're done with this section, so I need you to look at this picture, at the red stuff and the blue stuff, and see if you can identify everything, because we have covered everything in that drawing at the left. So go ahead and pause your screen, and I want to thank you for working hard and really understand this stuff before we move on to immune responses.